Hello and welcome back to this course on computer organization. So having written a couple of assembly programs, let us now move on to a very interesting problem with that of swapping variables. Okay, we want to swap two variables, two integers, x and y. Okay, both an x and y are things. So write an assembly program to swap two integers x and y, right? Now before we go into the assembly program, let us first quickly look at the C implementation so that we are familiar with what is being done. Okay, so I'm going to implement this without using any temporary variable. Okay, so what am I doing here? I have set x equal to 22, y equal to 99, and I'm printing the value of x and y before we perform the swap. Okay, then we are doing x equal to x plus y, y equal to x minus y, and x equal to x minus y. These three steps will swap the values of x and y, right? Then I'm again printing the value of x and y after this. So what you see here is very straightforward. X equal to 22, y equal to 99. After the swap, x equal to 99, y equal to 22. So clearly the swap has happened here and everything is very good as expected. Okay. Now what I am going to do, I am going to, as usual, comment out this portion of the code that does the swap in C, but I am going to keep my two printfs before and after the swap exactly the same. Okay. So now what I am going to do here is I am going to say underscore ASM, right? And you could of course perform the swap using either temporary variables in assembly, or we could also do it the clever way that we had discussed earlier, right? We are going to say push x, push y, pop x, pop y. Okay, so what does this say? What does this do here? Let's see. I hope this compiles correctly. Okay, perfect. So this has worked as expected, right? So we are basically getting push and pop. So let us maybe change the variables here to make sure that I'll do 33 and 88 this time, just to make sure that this output is indeed corresponding to this particular program. Okay, so you again compile and the value is 33 and 88 before the swap and 88 and 33 after the swap, right? Like I told you, the push and pop is basically simply going to push it in one order and you will pop in the opposite order because it's a last in first out stack operation that we are talking about here. Okay, so this is a very straightforward program that we wanted to write. The next program is slightly more interesting, okay, and it's very important to first understand the C implementation itself, okay, where I am trying to write a function to swap int b. Okay, so what I am going to do here, I am going to write down so let me do this. I'll call this a and b deliberately so that I differentiate between the function call and what is in the main, okay, so that it doesn't confuse us with this. Okay, so let's a equal to a plus b, a equal to a minus b, and then I'm going to print this guy exactly in this same way. Okay, so I will comment out this assembly part also that we wrote, okay, that we swap, and now instead I am going to call this function which is going to perform the swap of x comma y. Okay. The idea is the x and y which is sitting in main should technically get swapped using this function. Okay. So let us see first of all what is happening if that were the case. Okay. So let's see. So what do I have here? I have set int a and b, right? So let me just see this, a equal to a plus b, this should be b equal to a minus b, yeah, okay, only then this will work correctly. A equal to a, no, sorry, this should be b equal to a minus b and then a equal to a minus b, I am sorry, yeah, this is the correct implementation of the swap. Okay, so okay, very good. So now with this x and y and a and b, we know which function is actually doing the printing for us. If it says x and y, it means it's coming from main, otherwise it's coming from the function swap. Okay, so let's see what the output is first of all. It says x equal to 33, y equal to 88, and then we are calling the function swap. So you look at this. So after the first print here, we are calling the swap which is here, and we enter this function. It says it is just, of course, the first thing you are doing in the function swap is to print a and b. So what did you pass? You passed 33 and 88, and therefore you are going to print 33 and 88 exactly in that order. No swap has been implemented. Now you do a swap of a and b, and then you print a and b again. So as expected, what you find is the function has successfully swapped the values of a and b that were passed to it. Okay. But when you come out of swap and do the final printf here, you find that x is still 33 and y is still 88. So that means that the function swap has only swapped something locally within its function, but not been able to swap what was in main. Okay, this is a very important point to first appreciate before we jump into the assembly implementation of this whole thing. Okay, so now in order to fix this problem, what do I need to do? I basically need to say that I need pointers, because as you will see later in this course, C passes by value, and therefore a copy of the variable in main is sent to that function. Okay, so therefore first if I want to do this, I need to say this. Okay, and then I say star A equal to star A plus star B. Okay, watch this. And okay, and here when I call the function swap, I need to pass the address of x and y to it. Okay, because now the x and y are sitting in main, I am passing the address of x and y to this function swap, and in swap I am dealing with values that are pointed to by this a and b. Okay, so sorry, the last printf here also should be star a star b. Only then this will work correctly. Okay. So let's see what the output now is. So this is very interesting. So the C implementation in order to write a function to swap two variables is as follows. You take two pointers a and b and you pass the address of x and y. Of course, when you enter this function, the a and b initially will only point to the original values, nothing has been swapped. So that's why you see the first two printfs are very similar, x equal to 33, y equal to 88, a equal to 33 and b equal to 88. Then I am doing a swap operation, star a equal to star a plus star b. That means I am now dealing with values that are sitting in main. Okay, so I am doing, when I say star A equal to star A plus star B, the x in main is actually being modified to x equal to x plus y. Okay, likewise the three operands that the three operations that you do in this sequence will swap x and y in main, right? And therefore, of course, now when I do printf a equal to %d, b equal to %d and do star a star b, the swap happens. So this swap happened even last time, even when I passed by value. So the first three printfs out here were actually similar even for the earlier program where I had void swap of int a comma int b. Up to this point nothing has changed. But when you come out of the function swap and print the values of x and y again, you find that these two have got swapped in main as well, and that's why you see x equal to 88, y equal to 33 now. Okay, so this is how we implement a swap function in C itself, right? So we have not spoken anything about assembly programming yet right now. Now what do I want to do? I want to just say replace this particular function here, okay, replace this particular sequence of instructions here in assembly so that I am able to perform the swap. Okay, so let us look at what all we have to do, right? Remember, star A and B are themselves addresses, right? They are pointers. So if I want to deal with the value pointed to by the address, then I need to do this register indirect addressing. Okay, so for example, if I want to do this, right, if I want to do, let me start with this. So A push B, pop A, pop B. Okay, so let's see what the output of this program is going to be, right? So this is very interesting because what we have actually done is we have simply, the first two printfs are exactly the same. In fact, the first three printfs are exactly the same. Okay, so what we have done now is we have done the same operation that we did in main, push x, push y, pop x, pop y, on the addresses, because now A and B are addresses and not pointers. Okay, so let me also do one thing so that we understand that these are explicitly addresses and not values. I will rename this to PA and PY. Okay, by the way, that's why it's very useful to also deal with correct naming conventions. Okay, pop PA, pop PB, and here also I will say PA and PB. Okay, now the advantage is when I see this printf down here in isolation without even knowing what the earlier lines were code or what the function declaration is, I know P means it's a pointer, right? And therefore I have to deal with that appropriately. So int star, sorry, PA and PB, yeah. Good. I think this should fix all the problems and Okay, so now what we have done is we have simply done the same operation that we did in main on the addresses. So we have pushed PA, we have pushed PB, popped PA, popped PB, right? Now we will see what this means physically later in this course. Okay, but for now let's just look at the execution of the program. X equal to 33, y equal to 88, because that that particular line, the main, nothing has changed. When you enter and you just print again star PA star B, nothing has changed, no swap has happened. But after that, when you do push PA, push PB, pop PA, pop PB, the two addresses have got reversed. Okay, and therefore what you see is the A and B, when you do the the printf, this particular printf in green, this printf here, it will swap the values also, because I am doing now the addresses have got swapped and you are looking at the values pointed to by those addresses, and therefore that also will get swapped. But when you come out of the swap function and come back to main, you see that x and y in main have not got swapped at all. Okay, so really this is still not sufficient and it is not the same as doing this operation that we did in C. So in order to do that, I will tell you what we have to do. You have to do push EAX comma PA. So no, I am not push, I am sorry, move, right, move EBX comma PB, right, and then I am going to do contents pointed to by EAX, EBX, and I will be clear here, D word pointer, okay. Yeah. So now again let us understand what this whole thing, oh there is no PA because there is no capital PA, it has to be small p and capital A. Yeah, very good. So hopefully this should fix the problem. Yeah, so now you see what has happened. The first three printfs, of course, you know, there was no change, there is no real difference now also, because the swap was happening locally in the function swap, right? The two values were getting exchanged. But when you come out of this function, you find that the swap has happened in the main as well. Okay, so this is a very interesting point, because what we only did was moved the addresses PA and PB into the registers EAX and EBX, and then we pushed contents pointed to by EAX, right, onto stack, contents pointed to by EBX onto stack, and then did a swap, right, and did a two pops in the same order, and thereby enabled the swap of the original variables that were sitting in main, and that is why you see that the final x and y this value print also has reflected a swap in the variables. Okay, so what it basically means is that these pointers, you have to deal with data pointed to by these addresses. Okay, but what we effectively did, right, is the following. We did move EAX comma PA, move EBX comma PB, right, and then we did push contents of EAX, push contents of EBX, pop contents of EAX, pop contents of EBX. Okay, there is the, of course, I am leaving out the D word pointer, that is implicit. But now my question is, if you look at this operation, why didn't we simply do push contents of PA, right, contents of PB, PA, right? Effectively this is what we are doing, right? This is what we are effectively doing. So what happens if I go and do that? So let us just look at that. I will just write one statement here. PA. Contents of PA. Let's see what it says. So it is doing some completely random arbitrary things. Okay. So this basically does not, make sense. Okay. It is doing some random thing here, and therefore you cannot be doing this operation at all. PB okay, so let's see what happens when I go ahead and do this. Yeah, okay, so this is, it is doing something very weird, right? So clearly the swap has not happened. If you look at the final printf, x is still 33, y equal to 88. So the swap has not happened, and therefore this instruction that we thought, right? So if you look at these two move instructions, it is nothing. Actually, it is simply storing that value of PA and PB in EAX and EBX respectively. So that has no bearing on the program, right? But this is not doing the job that we wanted. Okay. Now, in order to understand this, we have to go and look at what this PA and PB are exactly in memory. Okay, how these variables, right? After all, these are function parameters, right? X and Y are local variables. So all these variables are basically going to sit somewhere in the microprocessor or the memory appropriately, right? So unless we understand that, we cannot appreciate why this particular thing is not working correctly. Okay, so now I will revert this contents pointed to by EAX EBX. Yeah, this should also be EBX, right? And now what we should have been able to do is swap the values of x and y and a and b appropriately in both the swap function as well as the main, and that is exactly what you see here as the answer. Okay, so in the next week we will be looking at the exact translation of this particular C program or any random C program to its assembly output, and understand and appreciate what exactly is going to happen in the process of translating it using a compiler.